All right. Hi, my name is Marcus Mulder, and today I will be talking about the Nazca Plate. So the Nazca Plate I just chose because I thought it looked kind of fun. It was one of the smaller ones, and I thought that would be kind of fun to do. So the Nazca Plate is right here. It's kind of right next to South America. Um, it is a fully oceanic plate, as it says over here, and then this right here, this side right here, it borders South America on its west side, um, which will be important because that is one of the differing zones or differing boundaries than the rest. This is the convergent boundary, and then the other three are divergent. Um, so why that is important, because that convergent boundary, you can see South America is right here. That convergent boundary gets subducted under South America, and it causes this like volcanic activity. This chart right here shows all like the seismic activity, volcanic activity, and stuff like that. So you can see there's a lot on that west side of South America. And these like subduction zones that convergent boundaries cause can create many things like volcanic activity, like this chart shows. It can create earthquakes, landslides even, and then sometimes in like big cases it can create tsunamis. Um, so another thing that subduction zone created is actually the Andes Mountains. So the Andes Mountains is the longest mountain range, and it is also home to like one of the top like peaks and valleys. The highest peaks in the world. So I think that's pretty cool that this little plate kind of caused all that. And then over here on the right side, it also caused the Peru-Chile deep sea trench, which you can see by this black spiked line right here. That's kind of where that trench is. It doesn't show it exactly. This graph is for seismic activity for this plate boundary, which you can see there's some red right at the edge where that subduction zone happens. So you can see it's very, very active. And that trench just keeps going down and down because that's where the Nazca Plate subducts underneath the South American plate. So it just creates that deep and deep, deep, deep sea trench. So its neighbors, I kind of showed you in that first picture, the neighbors around the Nazca Plate are kind of differing. So there's only that one convergent boundary with South America, and that causes all that subduction and then all that activity around it. But the other three sides are divergent boundaries, and that is with the Antarctic Plate from the south, the Cocos Plate at the north, and then the Pacific Plate, which is on the west side of the Nazca Plate. And then compared to its neighbors, Nazca is one of the fastest, growing, fastest moving. If it were a race, I say right here, Nazca would get second place because it's the second fastest out of its neighbors. So I can say its neighbors, so that Pacific Plate is the fastest. It actually has the biggest range as well. It's 56 to 102 millimeters per year, which Nazca moves at approximately 80 millimeters per year. So it's kind of a little bit less than that highest 102 millimeters that the Pacific Plate has. The third is the Cocos Plate, which is on the north, that has 75 millimeters per year. And then there is the South American Plate, which is the slowest. It's about 27 to 30 millimeters per year. So yeah, very, very slow, very, very slow compared to the Nazca Plate. So this, it kind of shows a little bit better. These are what's around it. So there's the Cocos Plate on the north, the South American Plate on the east. There's that Antarctic Plate, which isn't labeled. I don't know why. And then the Pacific Plate on the west. So this kind of shows it has that divergent, should be another one here, divergent, and then right here is where that convergent is, where all those subduction zones happening. So you can see the Nazca Plate is kind of moving in a east, maybe southeast kind of fashion. And then this graph is actually the age of it. So you can see right here on the left side of South America is kind of where that Nazca Plate is, and you can see it grows very, very rapidly. The red is the newest seafloor. The red is the newest seafloor, the newest spreading that happened, and the Nazca Plate is almost entirely red. So it happens very quickly, and it moves very, very quickly. as you can see. So that is the Nazca Plate, pretty much explained, not too much to it, but I think it's pretty interesting that it has 3 divergent sides and then 1 convergent side. So yeah, hope you guys enjoy.